Okay, guys. So we are gearing up to start a new unit to finish out this 9 weeks. This is one of my favorite units, just because we get to do some fun things with numbers and equations. So this unit is going to center around systems of equations. Okay, and we're going to look at all different kinds of ways to find the solutions and the different types of solutions you might have. But we are going to be dealing with linear equations in this unit. And this is really where algebra begins. We did a little bit with linear regression and the correlation coefficient previously, but for me, right, this is where the fun begins. We've kind of branched out and away from what other grade levels have ever kind of approached before with numbers and equations. So, right? There are some skills we need to carry into this unit that are very important. Okay. And so the first one is going to be distribution. All right. And so we're just going to go real simple with this one. And right, these are our skills needed for the future. Okay. Um, Skills needed for the future. That's our title today. Just because we're not starting the unit today. We're just going to review to make sure that we've got some basic skills. So the first one, right, distribution. You're definitely going to need how to distribute amongst an equation or for the entire equation. All right, and we're going to talk about that in just a second, right? So let's just kind of go with something very simple, something like maybe 3x plus 4 minus 8 equals, I don't know, we'll keep it even, 24, right? Maybe it works, maybe it doesn't. I don't know. Um, so let's look at this one, right? So we've got the distribution happening here, right? Which is multiplication. I'm going to multiply that 3 times the coefficient of x, which in this case is 1, and the 4. So that becomes 3x plus 12 minus 8 um, equals 24. Right? 3 maybe might not have been the best choice there, but it's okay. So 3x plus 4, right? Because now we are combining like terms, right? So another one equals 24. So we would subtract the 4 and from both sides, and we have 3x equals 20. In this case, we'll divide by 3, and we would get x equals 20 thirds. Okay, and I would leave it in that form for now. One, it's a repeating decimal, so we don't want to change it to a decimal. But two, right, numerator and denominator fractions are ultimately the only way we can work with them, or the easiest way. You can work with mixed numbers, but then it turns into a very layered approach to fraction arithmetic. Okay, so let's just think distribution, right? That is multiplying that number on the outside by everything on the inside. Okay, that's one skill we're going to need to take forward into this next unit. All right. The next one, right, is going to be so slope intercept to standard form. Standard form conversion, right? So how do we go from slope intercept to standard form? This is another big skill in this unit, and vice versa, right? How do we go from standard form to slope intercept? We need to be able to go in both directions with these equations, primarily because of the different manipulations that we're going to do in this unit. Standard form for me is actually going to be preferred unless we're graphing something, right? Um, Slope intercept is definitely the preferred graphing approach. All right, so just going to look at just a random slope intercept equation, right, and convert it over to standard form. and then we'll go back to that equation. So let's go y, let's say 7/3 x plus 4. Okay. So that is our slope intercept form, right? And we're going to take that and go to standard, and then we'll reverse the process. Okay. So, right, we've got here this slope intercept form equation, and we got to get rid of, right, slope intercept to standard. Standard form is, okay, let's, maybe we should probably y equals mx plus b. That's slope intercept, where standard is ax plus by equals c, right? So these three, right, are all whole values. They're integers, right? As Alex would say, we've got integers here for a, b, and c. No fractions, right? No fractions allowed in standard form. So we've got to get rid of this fraction. That's the first thing I want to do. And so the easiest way to do that is to focus just on that number. That's the only thing I need to worry about, is that 3 right there, okay? That 3 is what's going to cause me, to not be in a standard form if I can't get rid of it. But the easiest way to get rid of that is to multiply everything, right, by that number, okay? So I've got 3, right? We could multiply everything by 3, and this is kind of like where that distribution approach, right? So we're going to take that 3 and multiply it times everything all the way across, right? Multiplying 3 times 1y, well, that is 3y, okay? 3 times negative 7/3, okay? And so what happens here, right, is you've got 3 over 1 times negative 7 over 3. And essentially, those are canceling each other out. So we've got negative 7 over 1. Well, that's just going to leave me with negative 7x, right? That's why we focus on that denominator. And then 3 times 4 is 12. Okay. So we're almost there, right? Now we've got everything on a nice one level flat plane, all integer values for A, B, and C. But in this case, A is here, needs to be over here, right? So I need to get rid of the 7x over here. So I'm going to add it. Okay. Adding that 7x to both sides. Can't add 7x's to 3y's. So these two are going to essentially cancel each other out and leave me with just the positive 12. And I've got 7x and I've got a positive 3y, right? So there is my standard form, right? So we went slope intercept to standard form. Okay, so let's take that standard form and then go to slope intercept. Now we already know what the answer is, right? It's right there, right? But it's the process, right? We want to make sure that we can do, we have the skill to transfer that over. Okay. Now, if you remember all the little tricks, right? So your slope is always going to be opposite A over B, and your y-intercept, right, in this case, is always going to be C divided by B, for just quick conversions. But again, that's a trick. And if you elect to learn that trick, to really learn it, then you can use it. But if you don't commit that to memory, right, it's not a skill, right? You're not using a skill here. It's just a trick, right? So if you forget it on a test, well, then you can't use it. But skills, right? Skills, once you've acquired them, they never go away, right? It doesn't matter what the numbers are. We can manipulate things as needed. So the first thing, right, I want to do to convert this is move that 7x, right? I need this x term on the right side if I want to go to slope intercept, right? Slope intercept always shows x opposite y, right? It's on the opposite side of the equal sign from y. So I'm going to subtract 7x. And essentially, right, it goes away and I'm left with 3y over here. Well, on this side, right, I cannot take 7x from 12. So the 12 just kind of bumps out. And this just kind of keeps my format the same. So I've got negative 7x plus 12. And lastly, right, in order to be in slope-intercept form, I need y equals, right? Only y equals. So I've got to essentially get rid of that 3 in front. Well, how do you create the 1 in front of the y's? Well, you divide by the coefficient. So the coefficient here is 3. So I'll divide by 3, creating that 1y, right? That big 1 right there. So we've got y left over here. On the right side, everything gets divided by 3 because I divided everything on the left side by 3. I got to divide everything on the right side by 3. Well, negative 7 does not divide by 3 well, so we're going to go ahead and just leave that alone. Because it's slope, we want a numerator and denominator because that's going to tell me my right up and over approach, my rise over run. But 12 does divide by 3 and gives me that 4. Right? And again, we knew this answer ahead of time. It's right there, right? That's what we started with. But you can see, right? We've gone through the process of going from slope-intercept to standard and then brought that standard up and converted it back to slope-intercept. Again, using the tricks would have easily gotten us there, right? The opposite A over B, well, A was 7, so opposite A is negative 7 over B is 3, so negative 7 over 3. C over B, that's going to be 12 divided by 3, positive 4, right? So we can jump right over into slope-intercept if we remember those little tricks. But again, you have to commit them to memory. You can't just rely on them and then forget them because then they're not there. Okay, last little bit that we're going to need going into this unit. All right, because we are going to be utilizing some graphs here, we have to remember the process of graphing an equation. All right, so we'll start with something pretty simple and say it's y equals, say, negative 2/3 x plus 3. Okay, how do we graph that, right? So graphing. We have to remember, what do these things mean? Okay, the position of the number, the variables, etc., matter. Okay, the coefficient of x is our slope. The constant by itself in a slope-intercept form, that is our y-intercept. Hence the name slope-intercept, right? So again, slope tells us rise over run. Okay, so we always go up and down and then left or right, depending on the number. The y-intercept, right? Y-intercept is the y-axis point. Okay, that's our starting point. Start there. All right, that's our starting point for graphing. So just a quick graph, nothing fancy. Doesn't have to be right. 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, right? So just a little bit in every direction so we can get a good little graph going here. So again, start with your y-intercept. In this case, it's positive 3. So on the y-axis here, right, I'm going to go up to positive 3 and I'm going to place my first point. Okay, that's definitely a spot on this line. And then from there, I follow the slope. Now, keep in mind, right, thought bubble, depending on how I need to move. I could go down to right 3, right? That is down and right. Or I can flip that sign to the bottom, and this is up 2 and left 3. And both of those follow the same trajectory. They both follow the same movement. Okay, so depending on how I need to move, I can, manipulate that slope as needed. But here we go, right? I know it's a negative slope. So I know, right, that line should travel like this, right? From left to right, it's falling. So we're going to go down 2, right 3, down 1, 2, right 1, 2, 3. There's my next point right there. Okay, and you can see, right? If I connect those two dots, there I have it, right? It's a falling slope. But let's follow it the opposite direction, right? So let's go up 2 and left 3, right? That's flipping the sign down to the bottom. Again, only one can be negative. If they're both negative, then it's positive. So we're not going to keep the negative for both. We're going to put it down on the bottom just to move in the opposite direction. So we're going to go up 2, 1, 2, over 3, 1, 2, 3, and we have our third point there, which just gives us a little bit more accurate line. And if we connect those dots, right, you can see they all follow that path. And we could continue if need be, but there's our line, right? This is what's going to help us graph um, in a slope intercept fashion this unit. All right, so let's go with one more. So let's say, let's go negative 2x plus, I don't know, keep it small. 5y equals 15. Let's go negative 12. Okay, just so that things are a little different for us, right? Now, we can't graph from standard form, right? That's just not something we do. One, we can't identify slope. We don't know the y-intercept, but this is where, again, those tricks can come in handy. But if not, we need to rely on skill, right? And so we'll move the 2x to the other side. Moving 2x over, I end up with 5y. Well, we can't make that negative 12 because that doesn't work. With the 5, let's just go ahead and keep it negative 15. And we're going to go 5y equals 2x minus 15, divide by 5, divide by 5, divide by 5. And I get y equals 2/5 x minus 3. Okay, so now I know my slope is 2/5. My y-intercept is negative 3. I can graph this. Okay, and again, just a real simple, quick sketch of a graph so we can get an idea of what we're working with and what it should look like. Get a little practice in and call it a day, right? So first thing we start with, right? Start here. Right, so 1, 2, 3, there we go, right? Negative 3 on the y-axis, my first point. Then we're going to follow that slope. That slope says 2/5. That means up to right 5, right? And if I needed to, I could switch the signs and I could go down 2 and left 5. It's going to follow the same trajectory. And we'll prove that in just a second. So 1, 2, 1, 2, 3, 4, 5. There's my point, right? Or we could go down to 1, 2, and left 5. 1, 2, 3, 4, 5. There's my next point, right? So I've got my 3 dots there, and you can see they do follow that trajectory. And it matches what my mind's eye was thinking in that, right? It is positive slope. So just thinking about positive slope needs to go uphill, left to right, right? We're growing with positive slope. So I've got my graph here. And again, that's going to be a skill we need. We need to be able to graph lines given an equation in standard form or slope intercept form in order to find some information about systems. Okay. So that's it for today, guys. Just make sure we got some good notes, that we've kind of reviewed these skills. Make sure we're ready to go, right? So there's no slowing us down going forward on trying to learn things we should already know. All right. Any questions, comments, concerns? Give me a message. If not, have a good day and we'll see you next time. Thanks, guys.